Yes, good morning to everyone. Now we are going to discuss multipass assembler. In last lecture, we have discussed the two other design of assembler, that is the one pass and the load and go assembler. So now we are going to discuss the multipass. Now, if you remember, we have discussed in one pass the forward reference issue. In that, if some symbol occurred that is not yet defined, we are putting all those symbols in the symbol table and defining them as undefined. And later on, when they get defined, we are putting their actual addresses in the symbol table. Now, but in two pass assembler, this will not be allowed. It will not be allowed in two pass assembler, that if you are not defining the symbol and that symbol is being used first and later on it will get defined, it will not be allowed in two pass. That like example is here, three statements are here. Alpha statement is having the value of beta, beta is having the value of delta, but till alpha and beta, like if I will go to first statement, beta is not defined. If I come to second statement, delta is not defined. Till first and second statement, here beta is not defined, here delta is not defined. And this same situation we have discussed in one pass. But in third statement, delta is defined and that is equal to 1. Now that 1 will be given here in second statement, so beta will also equal to 1. Now beta will get value, so that value will be given here and alpha will also get value. And this thing is only possible in one. Later on, we are defining and we are updating the forward references list. Okay, but in two pass it is not allowed. So in that case one another concept came, that is multipass. So it is written here that if we allow multipass processing, in that case delta 1 will get defined in one pass, means in one pass when scanning is being done, delta will get defined, whole program will get scanned, and in that delta will get defined. When again in second pass, delta value will be given to beta, and in second pass beta will get defined. When beta will get value, that will be given to alpha. So in third pass, alpha will get defined. So using multi-define process, using multi-pass process, we can do this concept. But in two pass, it is not allowed. So this is, we can say, a motivation for using multi-pass assembly. When this kind of situation occur, we can use multi-pass to solve this issue, to solve the forward reference issue. We can run this code in multiple passes. We can do this assembling in multiple passes so that all the symbol will get defined. So continue. It is unnecessary for multi-pass assembler to make them more than two passes over the entire code. Like if we will consider the whole program, and in whole program if we keep on performing multiple passes, it will be unnecessary, it will be waste of time, because we only need multi-pass for those statements where the forward reference encounter, where the symbols are being used which are not yet defined. So that is mentioned here that it will be necessary only those statements where the symbols are not yet defined, or we can say where the forward reference need to be processed. So it can be used for forward reference statements only, not for the whole program. Now, how multi-pass assembler implementation will be done? How this can be done? How forward reference can be solved in multipass. So in that, use a symbol table. Use a symbol table to store the symbols that are not totally yet defined. Means which symbols are not yet defined. For that, make one symbol table, and in that we keep on putting the symbols. Okay. For the undefined symbol, like we keep on putting every symbol from our program in symbol table. We used to put in symbol table. Whatever the symbol keep on occurring in our program, we used to put all those symbols in our symbol table. We are doing that earlier in the topics. Now what we will do for undefined symbol, what entry we will put? For undefined symbol, what we will put? We store the name of that symbol, number of undefined symbols, means later on it will help for calculation its value. So for undefined symbol, what we will do? We will store its value, number of undefined symbol. Undefined symbol means if I am having one expression, in that expression, in that instruction, if some symbols are undefined, so how many symbols are undefined in that? So we will put that, and then the value of that symbol. We also keep a list of symbols which are depending on this undefined symbol. We will discuss one examples. From there you will better clear with the concept. Okay. So what we are doing here, we are creating one symbol table. In that symbol table, we are keep on putting all the symbols, and those symbols which are undefined, for them what we are doing, we are creating the entries. We are creating the entries, like which symbol is undefined. Okay, how many symbols are undefined in one instruction. Okay, and if that symbol is being referred by some other variable, other symbol, so we will make a list of those symbols. Or when that symbol become defined, we use its value to re-evaluate all the other values. Like they are saying, if the undefined symbol will get value, now we can calculate other symbols value which are depending upon that symbol. And we keep on doing that, we keep on calculating the values of other symbol in a recursive manner. So this multi-pass assembler implementation is somehow a recursive manner to get the values of all the symbols. So now from one example, you will better clear with this concept. See, this example is here. We are having 5 statements. First word is all f as z, that is equal to maximum length divided. Now, till this first statement, whole fsj variable, whole fsj symbol is equal to some value, but that value is having some undefined symbol. We don't know what is the max value of max length variable. We don't know till the first. After first line, the max length is equal to buffer and minus. But in this statement, buffer and buffer value is still undefined. So we don't know what are the values of buffer and. Later on, when we come to this, here is one variable, that is pvbt, that is equal to buffer minus 1. But again, till this buffer is not yet defined. So first statement, one symbol is undefined. Second statement, two symbols are undefined. Third statement, again one symbol is undefined. Now in fourth statement, buffer and reserve bytes. How many bytes? 4096. That means this much memory is assigned to buffer. Now till when we came to fourth line, buffer will get some memory assigned. So here we can put some value in that buffer, and that value can be used here in third statement, in second statement, and then maximum length will be calculated, that will be used by first statement. Now we are going in recursive manner when we will get the buffer value, and buffer and equal to star, so we can use some value for it. Okay, so now this is the table that we will generate. Okay, so till the first line, two entries will be there. First entry is regarding that whole statement. In whole first statement, what is that? Whole fsj is one symbol. Okay, and how it will be calculated? What will be the value? Maximum length divided by. But now in this thing, one statement, one symbol is undefined, so we will write ampersand 1 to define how many symbols undefined. Okay. Later on, we will make one more entry for first statement, that is our undefined symbol. Max length, star means not yet defined, and max length is being used by some another symbol, that is all fsj. So we will make a list and one arrow symbol to point to that list. Okay, so for every statement we will keep on making entries like this. So now till this is our first line. Now second line, if you remember, the second line is max length equal buffer and minus buffer. So now first line, as it is all fsj ampersand 1 max length divided by 2. Max length now get defined. Max length gets some definition, that is buffer and minus buffer. Now instead of star, we will put here buffer and hyphen minus buffer. But still in this statement, two symbols are not yet defined. So we will write here ampersand 2. This whole statement now defined, but these two symbols are not yet defined. And max length is being used by this symbol, so it is still in the list. Now because buffer and then buffer is not yet defined, so we will make entries for these both symbols. So buffer not yet defined, so we are putting star, and it is being used by max length. Again buffer and it is star, and it will be used by max. So this is still the second line. Now a third line was previous bt, that is equal to buffer minus 1. So again this is our first line, all fsj ampersand 1 maximum length divided by 2. Then our maximum length ampersand 2, because buffer and both are undefined, so 2, and it is being referred by all fsj. Now our third statement came, that is previous bt, that is equal to the value buffer minus 1, because it is having some value buffer minus 1. But in this statement again buffer is still not defined, so number of symbols which are not yet defined is ampersand 1. Okay, now if I will see here the buffer entry, buffer is still not yet defined. Previously it was used by maximum length, but now it is used by previous bt symbol. So we will add one more node to this link list, and in that we will put previous bt symbol. So this is still our third. When the fourth line came, in fourth line, the buffer will get some memory. So what we have to do now, we will assume some values, like here you will get more clear. We will assume some value for buffer and buffer end. Like if buffer is starting from 1034, it will end at 2035. Okay, that is buffer is small memory. So we are assuming that if it will start from 1034, so it will end at, after some location, it will end at 203. Okay, So now we will use this value to calculate other symbols. So if we will see previous BT, it is buffer minus 1. So buffer is 1034. So previous BT will be 103. Okay. Maximum length is buffer and minus buffer. So 2034 minus 1034, that is 1000. And all FSZ is half. So here should be 500. Here should be 500, half of this. So in that way, all the symbols are defined and their values are known, because we are going in passes. Okay, we are going in passes, and this is multiple pass. Like in one pass, whole FSZ get some value, but if you remember from the starting, all FSZ get value, maximum length divided by 2, but max length was undefined. In next path, again buffer and then buffer are used for maximum length, but still both are undefined. So step by step we are getting one symbol value, but others are not yet defined. So this is the end of this. So what we have discussed in this, we have discussed there are three design options available. One is one pass. In one pass, we have only one issue, that is forward reference. Okay, so in forward reference, we can solve in that way. We can keep all the reserved memories, all the statements which are reserving some memory at the starting of our code we can. And in one pass, a load and go concept is there, that we are loading at the same time when we are converting our code. So it will be ready for execution. And in that, we have to generate one symbol table. We need to put some addresses. And later on, when we get that symbol defined, we will put actual address in that symbol. In that way, all our symbol will get defined. So later on, we have discussed the multi-pass, and in multi-pass, one pass we get one symbol defined, in next pass we will get next symbol defined. So these are the three design issues. Thank you.